Lesson 7.4 is about factoring out the greatest common factor of an expression. So greatest common factor essentially means the biggest thing everything has in common. Biggest thing in common. I often like to call this the reverse distributive property, because distributing is multiplying everything by the same number. So if I have like 2 times x plus 5, I'd multiply by 2. Now I have 2x plus 10. Factoring out the GCF, the greatest common factor, well, now these two terms have a 2 in common. Divide by 2, divide by 2, and then it goes out front. So just like everything else we do in math, it has a way to undo itself. So the distributive property multiplies by each term. Factoring out the greatest common factor divides something out of each term. All right, so this just gets us 2x plus 10 by distributing, and then if we do the exact opposite thing, divide each term by 2, it gets us back to where we started. Now to make use of this factoring out skill we're learning, we need this concept called the zero product property, which is really obvious. It's just a name to something you already are aware of. If the product of any two numbers is 0, then at least one of those numbers must be 0. So I think all of us are aware that anything times 0, so no matter what I plug in for x, is going to come out to 0. Okay, now similar idea, if I do x times y equals 0. I don't know which of these is 0, x or y, but at least one of them has to be for this to be true. Can you think of any two numbers multiplied together that would make 0 without either of them being 0? The answer should be no. If I do -2 plus 2, I'll get 0, but if I do like -2 times 2 and choose opposites, I get -4. Or if I do 1/2 times 2, well, that's just 2 times 1 and 2 times 1, I get 2 over 2 or 1. There's just no way to make this happen without one of the numbers being 0. So the zero product property is kind of going to guide how we solve equations this lesson. So this is what a zero product property problem looks like. So these are things that are already in factored form. We will learn how to get bigger equations to look like this later this unit. But this is a factor, and this is a factor. So to get these two things to multiply together and equal 0, 2x can be 0, or x minus 4 can come out to 0, and in either one of those situations, we would have 0 times something. All right? So if I solve each of these equations, x equals 0 is one possibility. This one I have to add 4 on both sides. X equals 4 is another possibility. These are my solutions. Because if I plug 0 in for x, 0 minus 4 is -4. And then 2 times 0 times -4 is going to be 0 times -4, still 0. Or if I plug 4 in, 4 minus 4 is 0. Same result. If at any point we're multiplying by 0, the whole thing is going to multiply out to 0 in the end. So that's the role of the zero product property. Do the same thing over here. X minus 3 is a factor. If that equals 0, the whole thing will equal 0. X minus 9 is a factor. If that equals 0, the whole thing will equal 0. Some quick algebra steps and we'll get our two answers. So 3 is a solution and 9 is a solution. Now what's neat about these are these happen to be parabolas in disguise. We're just looking at the factored form, but these are parabolas, or in this case, quadratics, which means if I distribute it, I would get x squared somewhere. So we'll learn a lot more about this in Chapter 8 as well. It's where we do everything with graphing, quadratics, and whatnot. So just a little preview forward. The reason these have two solutions is because the graphs actually happen to look something like that. they're curved, and these are my solutions where it crosses the x-axis. So the zero product property tells me where a parabola crosses the x-axis. It's actually kind of neat. We'll look at a lot of applications. This is one of the more useful things you learn in Algebra 1, most applicable things in areas outside of school. So now let's do some factoring, and then we'll solve entire equations by combining these two ideas. So we want to find the greatest common factor. Let's take a look. Always look at the numbers and then each separate variable. So I guess we could have x's and y's in a problem, but let's look at the numbers first. Got a 4 and a 24. What's the biggest thing I can divide both those by? 4 is obviously divisible by itself. 24 is divisible by 4. 4 times 6 would get us 24. So I can divide out a 4. What else can I divide out? Let's take a look at the x's. All right. How many x's can I divide out? This one has 4 to give me. This one has 3 to give me. I can't take 4 because this one would run out. So I can only take 3 of them. So I can pull out of this expression a 4 and an x cubed by dividing. So what's the result of this? I get 4x cubed in front of a pair of parentheses. 4 divided by 4 is 1. X to the 4th divided by x cubed, property of exponents. There's 1x left on top, so just x to the 1st power. Plus, what's 24 divided by 4? That's 6. X cubed divided by x cubed. There are 0 x's left. They all got canceled out. So our factored form is 4x cubed. We don't need the 1 there, so I'm going to rewrite this. 4x cubed times the parentheses x plus 6. This is factored form. All right, so we found the biggest of each type of information, I guess. Numbers first, and then each variable that shows up in the problem. So you can handle them all separately. It's break it down into pieces like I did. It'll help you out a lot, especially with bigger things. Now we've got 2 things here to solve. When you see an x squared, you want to use a slightly different strategy than our normal equation solving techniques. I'm going to show you something incorrect that will get us half of the possible answers. Minus 8x, 2x squared equals negative 8x. Divide by 2, divide by 2. X squared equals negative 4x. Divide by x. Now the exponent's gone. X equals negative 4. That's it, right? I did it. Yay, congratulations. Except that is not the whole solution, okay? This only works, well, it's hard to give you that rule right now because you don't have context to understand why, but if 0 was ever going to be one of our solutions, this will not find it for us. So factoring has to be our strategy to get the most full solution. So I'm going to factor out the greatest common factor. What are 2 and 8 both divisible by? They're both divisible by 2. And then 1x and 2x's, I can take out a single x. So now I have 2x, and then in parentheses, 2 divided by 2 is 1. X squared over x is 1x left. And then 8 divided by 2 is 4. X divided by x is no x's left. So now I'm in factored form. Now I do what I do at the start of the lesson, is each different expression can give me a solution. So this one I would divide by 2, and I get x equals 0. We didn't get x equals 0 before. That one was missing. This one I subtract 4, and I get x equals negative 4. We did get this one. We had one of the answers, but by doing it using our normal algebra steps, actually lost the 0 solution. The reason for that is you're not actually allowed to divide by 0. So if x was going to be 0 and you divide by x, you lose that solution in the process. It's a weird thing to think about, but the way our algebra steps work, it's called checking. It's called checking for domain restrictions. So as soon as you divide by x in an equation, you make 0 a domain restriction. So it's a weird idea, but trust the process. This found us 2 solutions where our normal algebra steps only found us 1. So let's do it again over here. You might think to yourself, oh, divide by 6, divide by n, we'll get an answer really quick. Again, not how we want to approach this problem. What we actually want to do is get everything on one side. Typically, how you know you have a problem like this is you see a squared symbol. You see an exponent on a variable. So I have 6n squared minus 15n equals 0. Now we factor out the greatest common factor. What are 6 and 15 both divisible by? It's going to be a 3. N squared and n. I can take out a single n. And now we rewrite it, 3n, and then parentheses, 6 divided by 3 is 2, n squared over n is 1n left. Minus, because I had a minus sign here, 15 divided by 3 is 5, n divided by n is no n's left. Now we have our factored form, so we repeat this process. We want to find when each expression can be 0. Each of those should be a solution. Divide by 3, I get n equals 0. Again, if I just did normal algebra steps, I would have missed that solution. I would have only had half my answer. Then over here, add 5, divide by 2, and I get 2.5, or 5 halves. There's my solution. All right, so we need to make sure we factor instead of just trying to use normal algebra steps. All right, and that all comes from the fact that we have x squared. We don't want to lose information, and dividing by x when we shouldn't is how we will lose information.